When the moisture content in timber drops below fibre saturation point, it begins to shrink as the bound water in the cell walls starts to evaporate. However, the width, thickness, and length of a piece of timber will shrink at different rates, depending on how the board has been cut from the log. A backsawn board, for example, will shrink about twice as much across its face as a quarter-sawn board. On the other hand, its edge will only shrink about half as much. This is because tangential shrinkage is roughly double that of radial shrinkage. You'll remember from section 2 that backsawn boards are cut at a tangent to the growth rings and quarter-sawn boards are cut more or less along a radius towards the centre of the log. The main reason for this difference in shrinkage rate is that the ray cells, which run radially from the centre towards the bark, resist shrinkage along their length, and therefore have a restraining effect on the piece's radial shrinkage. The longitudinal shrinkage, that is, shrinkage along the length of the piece, is minimal as long as the piece has straight grain, because wood fibres will hardly shrink at all along their length. On the webpage for this lesson is a list of common timber species categorized in terms of their average shrinkage rates. Because shrinkage occurs at right angles to the direction of the grain, a variation in grain angle to the edges of a piece can result in warping as it dries. The most common types of distortions that tend to occur are bow, spring, twist, and cup. Uneven drying stresses can also occur when one edge or one face of the piece is exposed to the sun, which will cause those cells to dry more quickly. On the other hand, when one side is exposed to more moisture than the other side, the piece will again dry at different rates and therefore shrink unevenly. The outside or case of a piece of timber always dries faster than the core and therefore tries to shrink more quickly. If the surface tension increases to a point where the fibres can no longer hold together, cracks will develop to relieve the stresses. These cracks are called surface checks. Some timber species are particularly prone to the problem of collapse, which occurs when the cells buckle due to an excessive change in pressure. The effect is like sucking on a straw and holding your finger over the other end. Kiln operators are often able to restore collapsed timber by reconditioning the cells. In this process, the boards are heated and steamed until the cell walls soften and expand, allowing them to recover their shape. Once the timber is installed in a building or other structure, its moisture content will continue to rise and fall slightly as the humidity in the surrounding air changes.